There we go. Okay. We made it to the end of the first week of class, right? It's a big accomplishment. We're here, and as far as like logistics for the class, now we have like a schedule from today all the way through end of the semester, and then also our TAs, Carolyn and Peter, their contact information is up here on I was gonna say GitHub, but Husky CT, and yeah, so we're rolling. We're out of the gates, and the course is moving forward. I like calendars to kind of plan out like how the semester is going, at least for me. But the calendar in Husky CT keeps everything up to date for like when due dates are coming and all that. So I'll give a quick tour of the due dates in this calendar. I don't love Husky CT's calendar feature, but it is a calendar. It does exist, so that's what we're using. All right. So coming up is a main like submit that discussion post and that fork of our repository. So this is kind of like making sure that you have access to our discussions and that you have your own copy of course material. And then a week later we'll do like homework 1 submission, and then a couple of days later project 1. So the way that I kind of envision this course material going is that you're sort of reading material, working on the homework, coming to class with questions, and we can work through like debugging and that kind of stuff. And by time we submit homework 1 that Thursday, like Friday when we start the project, you're gonna have like all the information that you need. You just have to like connect the dots and build a project. So usually project takes less time, but it's more, there's like more things that you need to connect, more information and things that you're building. So the homework is kind of like a slowly adding solutions, and maybe they're not, sometimes they're hard to do, other times it's just taking code from a reading and getting it to work for your homework. But this is kind of roughly how I see the class going. We'll spend these first 2 weeks doing homework, and then a couple of days to get project 1 built out. And then same thing for like homework 2. Spend some time slowly building work into homework 2. A couple of days later, project 2. So then we'll fast forward. We'll repeat, rinse, rush, repeat, do this 4 times. So homework 1 through homework 4, project 1 through project 4. And then we get to, oh my God, and this calendar drives me crazy. But we get to the last week of, the last week of November is Thanksgiving break, and you'll submit project 4 before Thanksgiving break. So at that point, logistically, you're done with the course. Like there's no other required assignments once you turn in project 4. You can resubmit work. So if you want to go back, there's 2 options for the last like 2 weeks of the course. You can either go back and revise and kind of dig deeper into each of these modules, and then go back and improve them, and then get like whatever. If you're trying to get 100% on every assignment, then that would be the time to do that. Or there is, and again, this calendar is driving me crazy. Got to keep scrolling back up and down. Or this like module 5, homework 5 and project 5. You can do that. I guess we only have 1 week after Thanksgiving break, right? Yeah, just the way that things kind of turned out. That's all right. We'll figure it out. But you could work on module number 5, which is a brand new module, but it's all extra credit. So whatever homework 1 or 4 is worth, there you can get that many points added to your homework score. Same thing for project. Whatever project 1 through 4 is worth, you can add that to your project total score. Yeah, and that's like everything is ready to go. I think last class someone asked, like, can I just do everything like right now and be done with the course? Like, go for it. Knock yourself out. It'll be a long weekend, but then I don't know, you get to celebrate. But I guess the one thing about that is that probably TAs are going to stick to the same kind of grading schedule. So if you turn everything in all at once, like right now, I've never seen this done. I offer it every semester and no one has ever completed everything ahead of schedule. I've seen people turn everything in at the end of it, like at the very last second, but not at the very first second. But anyway, so the TAs will probably stick to a regular schedule of when something's due, they review everything all at once. So you won't get all your grades immediately, but you'll probably be like first in line for that round of grading. Cool. How are we doing so far? Did anyone like talk to anybody, figure out issues with syllabus or the way the course is running based on what you expect? The learning community that helps you demonstrate learning objectives? Nothing yet. Because editing the syllabus is surprisingly easy. Cool. Then we could jump right into like trying some Python stuff, Jupyter, running that kind of stuff. Hopefully now we've got a GitHub account and a NanoHub account. So GitHub is your main like so if you're working on something and you're not in class to ask a question, you can post like what you're working on and we can have asynchronous discussion about those kind of problems. In class, we can kind of work together and work through problems that way. But if you click this Jupyter Hub server for NanoHub, then it'll bring you to our open educational resource tool, and you can launch that tool. And click that launch tool, and that'll get you up into like a Jupyter notebook environment. So you can start clicking links and navigating through the material. And I just want to check in like where people are at and where, because usually there's some missing steps here and there. Yeah, so here, like you could, if you click on like interaction with Python, there's like the first reading assignment. Oh, you already did that. Okay, cool.
Wait, which one is PyTorch?
Yeah, like a tensor machine learning thing. Yeah, that one you can import PyTorch into any Python environment. Yeah. Yeah, Keras. Yeah, so you'd say like same way that you say like import NumPy, you would import PyTorch or import Keras. Yeah. Usually, I don't know. I don't know if we have it here in. Yeah. Yeah, this one. I mean, this is like a whole. Yeah. Tensor computation. Yeah. Yeah, anyway, you could do that. Okay. Yeah, that's cool. I'm just trying to get back to where I saw most people. There we go. All right, cool. So it seemed like everybody was able to get to like a notebook version of our website. Right now we're here in like getting started with Python and like using Jupyter. If you've been in my classes before, I probably already made you interact with Python, go through that notebook. So if this feels easy and familiar, that's good. That means that you're like getting better at it. Repetition is the key to learning. Repetition. But you can navigate like through this notebook, so all those blue links will get you to the next steps of the readings and the homeworks and all that. Did anyone get an error yet? Yeah? Oh, no? No error? That means no one's doing any work. If you're not getting errors, you're not actually coding. Yeah, yeah. You should be getting like, you should come up with something of like type errors and module errors and OS errors. Otherwise, like what's the point? Like what, you're just playing it safe and always doing simple addition and subtraction. Like we gotta be like breaking stuff. That's the goal today. It's like break some stuff, figure out how to fix it. Oh, and let me give you, so if you don't use Jupyter very often, or if it's been a while, or if you have sworn it off and you didn't want to use it, but now I'm forcing you to, let's give like a quick, is this working? There we go. All right, so right now, my computer is going to display what keys I'm using, just to show you like how I can navigate. So using arrows, you can kind of change what cell is highlighted if you're just trying to like read through the notebook. You can also scroll because it's an HTML web page, so you can scroll through it. And then the next step would be like if you're looking at code and you actually want to run the code. And let me get to the point where. So X is like deleting stuff. I'm gonna get back here, start editing. Shift Enter will run the code. And if I want to run it but change something, like add a new cell of like, hey, I want to run this, but I also want to work on something else, I can hold Alt, Enter. Now it'll run the cell, give me a new cell to work in. So first I printed hello world, but now I want to print, oh my god, in this. I don't know why it won't let me. Hola mundo. And I don't know how to get the upside down one. There we go. Hola mundo. So I want to run the first bit of Python code, but I want to change it so that now it's Hola mundo instead of hello world. So that's a quick. Those are the quick tips for Jupyter. Is that arrows will move you around. If it's green, that means that I'm editing whatever I'm doing. So as I start typing, it'll type in that cell. If I hit escape, now it's blue. Now it's just selecting that thing. So blue is like just grabbing cell thing, like the actual cell that runs code or has information. And then green is like changing what's inside of it. So the thing that kind of drives some people crazy is that just because I changed the cell doesn't mean that I executed the cell. So right now I added a variable called out, and it's bonjour nom. But then when I go to print out, it's going to tell me, give me an error. And this one is a pretty straightforward error saying that this variable out is not defined. But reading errors, the best way to read Python errors is start at the bottom and work your way back up. So at first it's telling me, hey, look, a name error has something to do with like the variable that I'm using. A lot of times name error means typo, like there's a typo in your code. And I would love to like rewrite the Python kernel and just Control F everything that says error and just replace it with like oops, like name oops, type oops, just so it's like less, and change this from like red to, I don't know, something, maybe like rainbow colors of like, hey, let's work together. But anyway, so out is not defined, and it's like, but I did define it. It's defined right here. But I didn't run that cell yet. I edited it, but I didn't actually run it. So then whenever I say run, now it's telling me it's input number 5, not input number 2. Then I run this. Now it's everything's good. 5, 6, 7 all run in order, looking good. So that is both a feature and a bug for Jupyter, is that things are not, just because it's at the top doesn't mean it was the first thing that you ran. So that can be good as you're debugging things and you rewrite variables at the bottom and you finally get things to work, but it can be bad whenever you're trying to use things that you already defined, or you're not trying to use them, but they're run out of order. Yes, yeah, so usually, so a lot of times, like if you're thinking of like a top to bottom, it's called a script. So Python script is like, the first line gets run first, the next line gets run second, and so on. So that's like a script that's just gonna go through everything. So if I wanna run this whole thing as a script, going from top to bottom, I could just say kernel and then restart run all. It's gonna stop, it's gonna clear everything out. So all of my like memory that was being used, all the variables, they all get deleted, and then they'll get input one at a time, and it'll run through each. And now this would be like 1, 2, 3, and then the next lines down will be 4, 5, 6, 7. So that's a quick welcome to Jupyter. And there's all sorts of other cool shortcuts and stuff that we can use, but those are usually the things that people need. It's like, how do I move around? How do I edit? And how do I run? So Shift Enter runs it, moves on. Alt Enter will run it and give you a new thing to work in. Cool? All right, try to break some stuff. There should be, if you're doing work, then you should be getting errors, and then we can figure out how to fix the errors after that. Yeah, so we'll have 4 projects. First we'll do like numerical integration for like time of death, looking at like a transfer kind of problem. Then the next one is that one's like a New York Stock Exchange trying to predict prices. Random walk. Yeah, so we'll use like random walk hypothesis and see how long we'll predict the price. So in this one we use like Monte Carlo method. So we take a bunch of data, find the average change in price, the range of changes in prices, so like standard deviation, and then see if that is enough information to have the same price. So every day there's going to be a change in price, and we're grabbing. I don't know. Yeah. No, yeah. Yeah. That one, like, it feels random. Then Monte Carlo's a good way. Yeah. Okay. Yeah, sure. What's the opposite of short? But then you just buy the stock. So then how do you short? But how do you make derivatives off of knowing that it's going to grow? Stocks are price for some most high corporation stocks. Their prices are built before they're yeah, nature. No, you need like 5 years. Yeah, you're looking at growth over time. I got one. Look at it over 10 years. Yeah. Give yourself time in the market. Yeah. Exponential. Yeah. What is love that has that can emerge into a market? Sitting there, I don't know. Yeah. It's kind of scary. There's also saying the trees grow in the sky. There's got to be points. Yeah. There's cat. Yeah. Yeah. Yeah, that'll be perfect. All right, cool. So we've got like all, at least as I was walking around, seemed like the main things people were jumping into were homework. So let's jump into like, so first question that came up as we were kind of looking around was like, what do you want from this? Like, what are you asking from me? And here the volume is already kind of calculated, but it's V. So if I want to know, is that volume more than 1,000, I can ask for that comparison. And now I know that it's 1925 and that 1925 is more than 1,000. So true, that statement is true. And if I wanted, I can make it fancier. The volume is more than I can kind of combine like outputs and like text. And a lot of that, whenever I do stuff like that, mostly the person that is most likely going to be reading your code and trying to debug it is you. So this is just like a friendly reminder to yourself of why, what does that actually mean? Like, why did I do this comparison? Okay, so then the next thing that came up was, as I was walking around, oh man, I already have that. Is in this, like, how do I force B to be true? Because capital Python and lowercase Python are technically two different things, even though they're both referring, I mean, I guess you could say this is like Monty Python, but this is like Snake Python, because it's not a proper noun, but the computer doesn't know. Like, to the computer, it's like two completely separate things. So when I ask for string 1, string 2, it's going to tell me that no, those are not the same. And if I try to do something like upper, make string 2 uppercase, is this going to work? Will that fix everything for me? Will it recognize that Python is Python? That it's referring to the same thing? No? Why not?
Is upper making the whole word uppercase?
Makes the whole word uppercase. So when I look at the output from string 2 upper, everything is uppercase now. That can be helpful. Maybe that is what you want, that you want all uppercase. But if I want to see like, are the letters in this word the same as the letters in the other word, then maybe I just want to do it to both of them. And now I've got like all uppercase, that everything is just being compared. Or I could do all lowercase or something, but you know. Yeah, we can, so strings, you can index strings. So if I want to know like what is the first letter, I can ask for bracket 0 and it'll show me like just P. Or I could say, like show me the first two letters of the word, like 0 and 1. And indexing, the way that it works is the start colon stop, but not including. So it's up to 2, but not including 2. And then if I add one more, I could have one more colon. That would be the step, like what steps I want to take. So I could look at like every other letter. I don't know why I would, but now Python is PTO. PTO, parent teacher organization, yeah. What was it? Paid time off, yeah. PTA, I guess is what I'm thinking of, paid time off, PTA. Or I could start at 1, go by 2, and get just the YHN. But anyway, so I guess that would be another thing that I could say is string 1, start at 1, go to the end. Is that equal to string 2? Start at 1, go to the end. So there I'm ignoring upper and lowercase Python, but now Mython and Python and Cython would all be equal to each other. But it works. It does force B to be true. Yeah, if you say string 1, string 1 colon, yeah, is giving you starting at the second value. And this one's weird, especially if you're coming from MATLAB. Python is index 0, so 0 is your first starting point, and MATLAB is 1. So there's a couple of weird things about like when you're indexing, it's always off by 1 in your head versus what your code is. But those were the first two things that I saw. People like, what's going on? How do I do this? Or getting errors. Now we're starting to get errors, so this is it's more exciting this way. Cool. Other thing, did anybody else break something? Yeah. No? You gotta be doing. You need more work then. You gotta be trying more stuff. Should be broken stuff.
I'll consider that.
All right. Thanks so much for trying some Python today, and we're up and running. Let's go on Wednesday. We can like come back in. Yeah, Monday we're out, but Wednesday we can come back, keep troubleshooting, and go through some more demos this way. All right. Have a great weekend. Like this? Yeah.